There are amateurs of paradoxes who come to London not to go and see the exhibition. I was so prejudiced, in common with many others, by being overwhelmed with admiration at the marvellous spectacle. The impression, it must be admitted, is very grand. Nothing can be more striking than the first view of the transept. Facing you is a large tree, which has been placed, as it were, under a bell like a plant. Advancing, you make a tour of this immense dome, amidst verdure and flowers, the murmur of waters, and encounter at the other extremity 2 large trees enclosed in this prodigious glass case. 60 years were required for the building of St. Peter's at Rome. The new Houses of Parliament at London were commenced 15 years ago and are not yet finished. The Palace of the Exhibition was begun and finished in 3 months. Will it live like the roses, only for the season?
The palace lasted very much more than the season. It wasn't finally destroyed until 85 years later, when it was accidentally burnt down.
It had been re-erected at Sydenham in South London as the archetypal Victorian pleasure palace, after its 6 months as an exhibition building here in Hyde Park were over. But if the ideas involved in the Great Exhibition had implications far into the 19th century, in 1851, it was the exhibition building itself, the astonishing palace of glass, and the speed at which it was erected that really caught the public imagination. Yet, just how new and revolutionary was this building?
We're going to look at how the building was actually achieved, why it took the form it did, and at the scientific and industrial advances, if any, in the items exhibited inside it. The whole idea of an exhibition originated in the Royal Society of Arts in 1845. The Society had already held some small-scale exhibitions of manufactures, and 2 members in particular, Henry Cole and John Scott Russell, were keen to do more. At last, in January 1850, a royal commission was established to organise an exhibition with Prince Albert, the Society's president, at its head. Fired by Henry Cole's enthusiasm, and perhaps in the desire to outdo the French National Exhibition of 1849, Albert opted for an international exhibition in London on a grand scale. It was to be a celebration of the progress achieved by industrialisation, and, Prince Albert claimed, was to give,
under the stimulus of competition and capital, a true test and a living picture of the point of development at which the whole of mankind has arrived, and a new starting point from which all nations will be able to direct their further exertions.
a competition was held to design a building on the chosen site in Hyde Park. It had to be large enough to house all the exhibits, but also temporary, cheap and easy to build. 2 possible winners were selected from the 245 designs submitted. However, the building committee chose neither and instead produced their own design, largely the work of one of the engineers on the committee, Isambard Kingdom Brunel. This was large, all right, with a 150-foot high dome. But its 50-foot brick drum would be neither cheap nor temporary, and there would be no chance of selling the parts after the exhibition was over. Not surprisingly, the committee's design came in for a lot of criticism, and there was opposition to the exhibition as a whole. At the same time, the ambitious scale of the venture was public property, and with royal involvement, it could hardly be abandoned now. This potentially disastrous situation was resolved by Joseph Paxton, perhaps the archetypal self-made Victorian. He'd risen from being a gardener's boy to head designer for the Duke of Devonshire. He also managed the Duke's railway investments. And according to Paxton, it was at a Midland Railway Board meeting, early in June 1850, that he produced this sketch. Adapting the principles of his earlier iron and glass greenhouses for an exhibition building. It was simple, elegant, and best of all, quick to build. He probably discussed the idea with his close friend, the engineer Robert Stevenson, a rival of Brunel's, who was also on the building committee. The plans were laid before Albert, and the committee was persuaded to allow tenders to be submitted for this new design as well as their own. Only one company, Fox and Henderson, tendered for both designs. And significantly, Charles Fox was another close friend of Paxton's. Their price, £150,000. All the people concerned are shown in the so-called official portrait of the Royal Commissioners, except that about half the commissioners, and in particular Brunel, aren't actually there. Paxton and Fox, who were not commissioners, are, however, explaining the plans to Albert, a model of Paxton's great conservatory at Chatsworth at his elbow, while Henry Cole, the architect of the whole scheme, perhaps, smiles benignly on. This picture rewrites the rather hurried and dubious presentation of Paxton's designs as part of the official history of the Great Exhibition itself. Whether Paxton was advised to or decided for himself, he further preempted the committee by publishing his design in the Illustrated London News just 5 days before the committee's final decision was due. His design caught the public imagination and was promptly nicknamed the Crystal Palace by Punch. On the 11th of July, a bare 10 months before the opening date, the committee was forced to accept his design, though they asked that it be modified by the insertion of an arched transept. Finally, on the 1st of August 1850, construction of the Crystal Palace began. Iron and glass structures weren't revolutionary in 1851, but they were excitingly modern. Richard Turner had already designed the Palm House at Kew in 1844. Stripped as it is for restoration, it demonstrates how the very nature of iron and glass construction allowed the enclosing of huge, well-lit spaces with little or no interruption from supporting columns. The effect is airy and elegant and ideal for an exhibition space. And the possibility of repeating units meant that such buildings could be extended almost indefinitely. At 110 metres, the Palm House is barely 1/5 of the length of the Crystal Palace itself. The great advantage of iron and glass structures like this was that they didn't need elaborate foundations. But the elegant architectural form of the Palm House did cause some awkward problems. The decision to have a wider central section created an awkward conjunction between the main arches and the columns of the central hall. It required a piece of column balanced on the principal arch. On the other hand, the iron construction meant that decoration, rich or plain, could be simply bolted on. To produce these elegant curved shapes, the designers, Richard Turner and Decimus Burton, had to use expensive curved glass and specially shaped pieces at the ends. While the final result at Kew was a building of grace and simplicity, the time and expense involved ruled out such details for the Hyde Park building. Paxton's design showed a number of advances, which were the result of his experience in building the Duke of Devonshire's great conservatory at Chatsworth in 1837. Instead of expensive, specially made curved glass, that roof was built of standard flat panes set in this ridge and furrow pattern. The glass was both easier to make and fit. Paxton used the system again in a lily house for the Duke, designed in 1849 to house the rare Victoria Regia lily. Indeed, the story goes that Paxton got the idea for his lightweight roofs from the structure of the lily's massive leaves and the weight they could hold. The structural parallel between the lily and such buildings was recorded by the botanist Sir William Hooker in his description of the plant, published in 1851.
A leaf, turned, suggests some strange fabric of cast iron just taken out of the furnace. Its colour and the enormous ribs with which it is strengthened increasing the similarity.
It's a typically Victorian sentiment, linking the latest discoveries in the science of botany with everyday problems of industrial design and manufacture. The real innovation of the Crystal Palace, however, was the marriage of design with industrial production. The building was 1,848 feet long, 408 feet wide, and covered 21 acres. The speed of its construction was only achieved by the use of mass-produced, prefabricated parts. This is one of the same castings, seen in what's left of the old station at Oxford. The original station was built by Fox and Henderson in 1851, using a number of parts identical to those designed for the Crystal Palace. In the remains of the train shed at the back is the outline of a ridge and furrow roof, and the main structure consists of open iron girders. This one, identical to those used in the Crystal Palace, is made from a single piece of cast iron, with holes for the fixing bolts incorporated. But although cast iron was cheap, it was also brittle and not suited for longer beams, so they were assembled from pieces of the more expensive wrought iron. Although this was initially more costly in labour and materials, it allowed the girders to be the same depth as the cast iron ones, and that meant the columns could be simpler, with identical mountings for long and short beams.
The columns were simple, but also ingenious. They're cast hollow, otherwise they'd have been impossibly heavy. But even that was turned to advantage. In the Crystal Palace, they were connected to drains laid beneath the floor, and so used as so many invisible downpipes for the huge roof. It's a thoroughly sophisticated design technique, doubling up of functions and designing for ease of construction. But that was absolutely vital if they were to have any chance at all of completing the huge project to time.
Teams of workmen laboured in sequence, laying the foundations, raising the columns, and fastening the girders. And as each section progressed, the columns were braced with tie rods and sealed into the drainage system. As soon as the girders were in place, other teams began fitting gutters and glazing the parts that were erected. When the framework was up, the galleries were given simple boarded floors by carpenters who were then able to work under cover as the job progressed. There were special machines for cutting gutters and sash bars to hold the glass. And the roof panes were of course all of a standard size, fitted by teams working from special trolleys designed to roll along the gutters. Because Paxton and the engineers had produced such simple designs, there was little room for error. Nothing so vast had ever been built so quickly, and the interest in the enterprise grew, stimulated by the frequent progress reports in the Illustrated London News. Only the roof of the transept, with its daring laminated ribs, was non-standard, and raising the ribs caused great excitement. But the simple roofing system was easily adapted to run over the arched roof, and the result was a building that even its critics recognised as an extraordinary phenomenon. Yet the very fact that it was built so swiftly and by unskilled labour is clear evidence that it was the organisation rather than the design that was revolutionary. And in that, the building was certainly matched by its contents. The exhibits all 100,000 of them, were displayed country by country. But to accommodate the stimulus of competition, originally outlined by Prince Albert, the exhibits were also classified for judging in 4 main sections: raw materials, manufactures, fine arts, and machinery. Scientific research was represented by one of the 6 subdivisions of machinery: philosophical instruments, meaning scientific apparatus. This was mostly relegated to the galleries, and seems to have been exhibited more for mechanical ingenuity than for any radical contribution to scientific method. Significantly, the microscope that most impressed the jury was designed with a revolving table,
by which the microscope can be readily turned round for the convenience of examination by different observers, and thus rendered a social instrument.
The one large telescope that was prominently displayed was only a refinement of a traditional type. But if scientific advance as such had no real place within the exhibition, what of industry? The exhibition, after all, was of the industry of all nations. There certainly were some technically advanced exhibits. The great hydraulic press, for instance, used to raise the tubes of the Menai Bridge that Robert Stephenson had just designed. Then there was one of the cranes that Fox and Henderson had used in building the Crystal Palace itself. But I think these were impressive for their rarity rather than their importance in the progress of trade or industry. The exhibition's stress on manufacturing industry and consumer goods was reflected in the organisation. 17,000 square feet were given over to the display of cotton machinery from Oldham, Manchester and America. The technical descriptions in the catalogue may have been meant for engineers or operatives. But for the first time, the public was seeing in motion the machines that produced the goods they bought. The working looms, backed by a display of plaids on the wall, must have been an impressive way of linking the weaving process with the woven product. However, the looms themselves were only refined versions of the principle invented by Cartwright in 1786. 2 generations had merely multiplied the modifications. Even the gigantic jacquard loom for weaving the popular patent fabrics was just a larger, more mechanized version of another 18th century original. Yet even so, the machine exhibits occupied less than a quarter of the ground floor area. And in the commemorative volume of 55 pictures, only 3 plates illustrated machinery. And only one of those, machines in motion. And these clean exhibition spaces, with gleaming pieces of the latest machinery, must have seemed to the operatives who saw it a far cry from their own experience of working mills. The catalogue made a distinction between specialist manufacturing machines and those revealingly described as machines for direct use, like the railway engines that had brought so many of the visitors to the exhibition in the first place. Those were part of everyone's everyday experience.
With its 6-foot single driving wheel, Daniel Gooch's new 30-ton Lord of the Isles, built for the Great Western Railway, will have impressed many people by its size alone, let alone its mechanical sophistication. The actual engine was in service from 1851 until the late 80s, but now only models survive. Actually, models were also a feature of the Great Exhibition. They were chiefly used to display buildings, bridges, great civil engineering works, such as the Liverpool docks, which was shown complete with 16,000 model ships.
For all the exhibition was intended to promote the progress of all nations, it was not greatly concerned with improvement of the labourer's lot. Delarue's new envelope-making machine was applauded for producing 60 complete envelopes a minute. But there was no comment at the time that it was operated by 2 children who had to insert sheets of paper and remove completed envelopes at the rate of 1 a second. One of the very few exhibits that did demonstrate a concern for the condition of the workers was this set of model cottages to a design commissioned by Prince Albert.
Originally erected just outside the Crystal Palace, they've been rebuilt at Kennington, where they form an attractive part building. They are, superficially, very decorative, with their pretty parapets and even mosaic panels. But the basic structure is simple, and the plain window reveal reminds us that these were only artisans' cottages. The block, in fact, contains 4 flats, 2 on each floor. The idea was that these units could be reproduced vertically or horizontally ad infinitum. Even so, the flats were obviously too spacious and too expensive to be attractive to speculators, and the design was never taken up.
As well as playing host for the exhibition, Britain, in 1851, was undoubtedly the most advanced industrial country in the world. So it's no surprise to find roughly half the exhibition space reserved for British goods and exhibits. Yet, in spite of the comfortable assumption of British superiority, the invitation to other nations to exhibit was given in the belief that free trade and competition would benefit all. We shall see next time how far the foreign goods appeared to show up the poor quality of much British design. But there were also areas of manufacture that can now be seen as presaging the end of British supremacy. The centrepiece of the American section was this huge trophy of India rubber, a new material whose potential in England was barely recognised. In the British press, the USA was widely accused of having reserved too much space while having too little to exhibit. They did show the first mass-produced firearm, the Colt repeating revolver, yet it attracted interest for its present ingenuity rather than its future potential. The revolutionary new harvesting machine from America, the McCormick Reaper, was hardly noticeable alongside the British agricultural machinery. Most of these machines were hand-operated with only the occasional steam engine. But the British display covered 30,000 square feet of exhibition space. The bulk of the items on display were merely refined or enlarged versions of tried and tested types. Of course, the exhibition could only display the best of what was already available. The real innovation, mass production, required mass markets and massive resources to be truly successful. The McCormick Reapers, for instance, were designed and built to exploit the immense prairies of North America, not the modest fields of England. Looking back at the Great Exhibition, what seems important now is not so much what was exhibited as the process of building the Crystal Palace itself, an industrial exercise heralding the era of mass production.